It's free.
And how much does it cost?
It's free.
It's free, right?
Hi, welcome back. Good to have you here. First things, I got the dew shield printed finally. Had a bunch of problems with the 3D printer at work and had to print it in two separate pieces and glue them together, but it's all put together, flocked, it even fits. So I've heard tell that astrophotography is a rich man's hobby, that you have to spend a ton of money. Well, I don't agree. I have probably just a little over 800 bucks into my telescope and mount and everything all together, and I am doing astrophotography. Now, as somebody who spends $10,000 on a rig and buys PixInsight and every plugin available for it, is their stuff going to be better? I would hope so. Otherwise, there's lots of dumb people. But am I having fun? Yes. So tonight we're going to follow along on a session. I'll be using all free software from acquisition to processing, even some of it with AI. That's cool. We'll use things like Nina, Siril, GraXpert, Astrosharp with its new cool denoising algorithm, and of course GIMP. So we'll see if some idiot on the internet with a 30-year-old telescope and mount and a bunch of free open source software can make a passable image.
Ancient astronaut theorists say yes.
Let's try it. Okay, first things first. Let's pick a target and frame it up. So my favorite way is using Telescopius. So I'm thinking about a good Halloween target. So we'll click up here and go to Object. We'll click RGB 7822. And that shows up as a diffuse nebula. Click on that and it will show you some pictures of it up here. But as we scroll down, so we'll see how it looks with my telescope. I have it set to 812 millimeters, which is what the Meade SN8 is. And I have my DSLR entered right here. This is the nebula as it shows up with my framing. It is the Flaming Skull Nebula. I thought that was pretty apt for Halloween. It's upside down, but we'll fix that when we process it. I like the way this looks. You can actually set the camera rotation clicking here and changing the rotation, but I kind of like it at 0. So now we'll move on to Nina. Here we are in Nina. We have all the equipment connected, camera, manual rotator, telescope, guider. So the first thing we'll do is go to the Sky Atlas and type in our object name at the top. NGC 7822. There it is. We can see that this target is up all night. I have my custom horizon at the bottom showing where all my trees and houses and everything. So, okay, so we just click Set for Framing Assistant. Okay, once we get it looking the way we want, I usually hit Load Image one more time just so it centers it right. Okay, so we're obviously not going to get the whole skull in my picture, but I'm just going for the brightest part. I'm going to shoot at dual narrowband, so hopefully we can get some pretty colors. So next we hit Add Target to Sequence, Legacy Sequence. We're going the easy way. We want to unpark the mount, park it after we're done. Target options, we're going to slew to the target, center target, rotate target, and that will be a manual rotator when it figures out where it is in the sky. It'll give you information, say rotate your camera so many degrees clockwise or counterclockwise. and start guiding after. So we'll just put 200 or 120 in right now, 300 seconds. Lights, I'm going to turn dithering on, and we're going to dither every 10 frames. I like to dither, but I don't like to dither a lot because my mount has a hard time after the dither settling down, so I don't like to do it that many times a night. So we're ready to start the sequence. All we'll have to do is hit play, but first we go to the imaging tab, choose a manual focus target. Usually Deneb's a nice one. So we'll slew to the target, plate solve to get Deneb right in the middle, and then we'll throw on the batten-off mask and focus. And then after we focus, we'll do a 3-point polar alignment. I'll be doing all of this on my iPad while I'm outside. We'll go to that point. Okay, we are polar aligned, focused, and we're almost to astronomical dark. So we got the sequence all set up. So all we have to do is click start. We'll go to the imaging tab. It'll slew and plate solve and start guiding. All right, it's as easy as that. I guess we'll just let this go until the morning, and then we'll start with Siril. Okay, let's get started. Here we are in Siril. I have all my data in a lights folder. I've gone through them all manually, deleted all the bad ones, like where my mount didn't do its mount thing, and UFOs, Bigfoot, whatever. They're all gone. I don't usually take out the Starlink trails. They usually get, they will get averaged out in stacking. So I shot with a dual narrowband filter. So the script we're going to run is the extract HA03 script. That'll give us 2 black and white images, trying to mimic if I was actually shooting narrowband mono. So we'll run that script and be right back. Once the stacking is complete, we're going to end up with a results folder with 2 files in, with 2 images in the results folder, the HA and the O3. There'll be grayscale images, and that looks pretty cool. Other than we got some weirdness going right here. See what my O3 looks like. Okay, so first thing, we're going to do a background extraction, but I'm not going to do it in Siril. I'm going to do it in GraXpert, which has cool AI now. So all you do there is load an image, and we'll do the HA first. it does an auto stretch. So all we do is we make sure that our background method is set to AI, and we just hit calculate background. And there we have it. Even things out a little bit, so we'll save that processed image. Save. Load up the 03. Same. Calculate background. Okay. Save processed. Now we're done with GraXpert. Go back into Siril. Now we will do pixel math. We'll uncheck the use RGBK expression, so we just have the RGB filters left. Click the plus to add our two GraXpert files. And then for the red channel, we will use HA. For the blue channel, we'll use oxygen. And for the green, we'll put in an expression, 0.6 times HA plus 0.4 times 03. That just means we're going to use 60% of the HA and 40% of the 03 in the green channel. Click apply. And there we are. Close that. So now you can see we starting to look a little heavily. So first we'll do a color correction, and we can't do the photometric because of the dual narrowband, so we'll go to color calibration, choose a little background, use current selection, neutralize the background, and then take a big selection of our nebula and use current selection, apply that. Kind of brings the blue out, starting to anyway. We'll do a remove green noise also. All right, so now that's all we're going to do for now. We'll go into linear and do Starnet++. So go to star processing, Starnet star removal, pre-stretch, execute, and we'll be back in a minute. We are back. Stars are removed. Here's the stretched image, so we'll go to generalized hyperbolic stretch. So Deep Space Astro has a great video on how to stretch dual band images. I'm just following that, so if you want a better video, go watch his. We are going to go to modified arc sign and choose even weighted, and we'll do a pretty aggressive stretch first to get things to show up. Once we start seeing it, we'll apply, and then I'll find an area where I think the blue is going to be. Add that as a symmetry point. Stretch that a little more. Try and get some of the blue coming out. Apply that. And we'll go to the yellow part. Symmetry point, stretch that a little bit. Apply. Bring my black point up a little. Move the histogram all the way to the left without clipping anything. Okay, now we'll go into generalized hyperbolic transform, independent channel values. I'll just leave it here for now, set that symmetry point, and start stretching the usual way. Adjust my local stretch intensity. Stretch my blue a little. Okay, now we turn off the red and the green channel. Set my symmetry point in the blue area here. Stretch my blue values up a little. Now the opposite, turn on red and green, turn off blue. Set your symmetry point up here. Stretch that just a little bit more. And now we do a saturation stretch. Make sure all the channels are on. I'm glad it warns you. Okay, let's do one more color calibration. Same way, use current selection, background neutralization. We'll see how it makes these colors look. That's kind of cool. Now we will take this picture, save it as TIFF file. Save it as a 32-bit TIFF. Now we will go into Astrosharp. So I'm on a Mac, so I have to run RStudio and run the app from there, which is fine. It works just great. We'll load our file, which is a starless pixel. Find a good spot here. All right, now this slider here is the one we want to use. When we hit update sliders, it shows you your original image here, and it shows you the processed image here. So we just move this around, see what looks the best. Okay, once you have it where you think you want it, I just click on multi-core and full image, and it will process the full image. Back in a minute. It is done. So I'll show you my original image, my processed image. Looks a little brighter. Okay, so now we download the processed file. I like to close it before I do this next part, so we'll open it again. Now I'll open the processed file. And this time we're going to choose use AstroClean, which is the denoising program he has now. So same way, except for we use the aggressiveness slider this time. So we'll look at our previews and see what it looks like cleaned up. I like that. Okay, same way, multi-core, full image. And we'll wait for it to finish. Okay, we are back with the denoised image. Original, processed. So we'll download that processed file. We're going to name it denoise.tiff. Same place. Alright, we are done with that now. So out of our studio. Alright, so here's the thing. When you shoot dual narrowband, you lose all the color in your stars. I wanted colorful stars, so I shot about an hour of 60-second exposures, and I came up with the result.fit for it, and I ran Starnet on it, so I have starless and star mask. We're going to look at the stars right here. So we'll take this star mask image and hopefully we can pull some color data out of it. So first thing I'm going to do though is go into star processing and run dynamic PSF on the stars so it finds them all, and then run a full resynthesis on it. Then we can get rid of them. Close. So what that did, I hopefully made all my stars round. I still have a few problems with some of my edge stars not being perfectly round. So next I'm going to go, this is my own design. I go into Assign, go up here, go to Assign Transformation, and just do a small stretch first. Apply that, and go back to linear. Go to generalized hyperbolic transformation, and go to the modified arc sine transformation and even weighted luminance. And I'll stretch a little bit here. This seems to preserve my star colors better doing it this way. Remove my green noise a little. Okay, and now color saturation. I usually pump it up pretty good here. Alright, colorful star field. So we'll save that. colors.tiff. And we'll save that as a 32-bit TIFF also, because I'm going to be using GIMP, unlike those other stupid programs that can only use 16-bit TIFFs. So, be back in GIMP in a second. Alright, here we are in GIMP. Star field. Starless nebula picture. Okay, I'm going to do a little bit in GIMP. Curves. I don't know that I need to brighten it up too much, but I need to bring it down a little. Increase my contrast a little bit. Okay, so go to the stars, new layer. Control A, Control C, back here, and paste that into that layer. Anchor the layer, and screen mode. And there we are. So now everything's lined up. Flatten that. And now everything's lined up. I can get rid of all my stacking artifacts. So we'll just do a little cropping here. I don't know about this weird line right here. I think I'll just kind of crop it out. Must have been something to do with my darks, I guess. Okay, there it is. All free software, 30-year-old telescope. Best I can do. Found this interesting? Like, share, subscribe. Buy me a Diet Mountain Dew. Talk to you later, and clouds suck.